Perform the following operations. Give the answers in standard exponential form with correct sig figs. Okay, when you are adding or subtracting, uh, and you want to follow sig fig rules, you've got to line up the placeholders. So let's just do that right here. 37.2, 18.0, and 300. That's in the hundreds place, tens place, ones place, and they're all lined up. Now we can just add 2 there, decimal, bring that down there, and then 5, carry the 1, and 8 plus 5, 13. So there we go. So the thing to look out for here is which of these measurements has the least precision. Well, that has precision to the tenths place, decimal tenths place. Now this only has precision to the tens place. All right, so this measurement is going to limit the precision of our calculated answer. Okay, so in other words, since these are all beautifully lined up, nothing past this here. We can't have any digits here because the 380 measurement, we had no idea what this was, and we had no idea what that was, so we can't have digits in those placeholders. All right, now 380, that's 0, by the way, is not significant. If it was, we would write this in scientific notation. We would indicate it with a decimal there or a bar there or somehow, but with none of that, we just assume it's not significant. All right, so the least. All right, anyway, just repeating myself. So we're going to keep that 4. We're going to keep that 3. No, we're not, because the next digit is a 5. We're going to round our last digit up, 4, and then the rest are just zeros because we don't know. All right, milliliters. 440 milliliters. Now, I don't like leaving our answer like that because it just I'd rather, if our number ends in 0, I'd rather just make it clear that it is not significant by writing that in scientific notation. And so there's our implied decimal. Move it over 2 spots that way. So we'll just write 4.4. Again, if it was significant, we would just intentionally put that 4 there or that 0 there, but it's not. So 4.4 times 10 to the 2 milliliters, and that's how I would write my answer. Let's move on. B, multiplication division. Beautiful. Much easier, in my opinion, and much more common in chemistry. So let's just take out our calculator. Now, let's see, 0.57 times 0.86 times 17.1. All right, calculator spits out 8.38242. We're not going to need all that because when you're multiplying or dividing, sig fig rules says your calculated answer can't have more sig figs than the measurement with the least. So this has 2, that has 2, that has 3. Your answer has to have 2. Can't have more, can't have less. Should have 2. So we're going to keep that 8. We need one more. Now peek at the next digit to see if your last digit rounds up. Again, it does. So it's going to be 8.4. Now, centimeters times centimeters times centimeter. That's length times length times length. That's volume. Right? So that's cubic centimeters. There's the answer to B. And let's go to C. I'm going to do that way down here. All right. These are in scientific notation. Now, if they wanted you to use a calculator, in this kind of a lesson, I'm sure they don't want you to use your calculator, but you can in our class. All right, when you're dividing numbers in scientific notation, you're going to do that operation with the coefficients. All right, in other words, let's punch this in our calculators. 8.13 divided by 3.8. Okay, let me do that again. That doesn't look right. 8.13 divided by 3.8. Yeah. Okay. So again, you're multiplying or dividing. So the number with the fewer number of sig figs is going to determine how many sig figs your answer will have. All right. And in scientific notation, every digit in the coefficient is significant. So it's 2.1. The next digit is a 3. So that's not going to round up. It's going to keep that 1. Times 10. Now the exponents, since the bases are the same, we can subtract. 4 minus 2 is 2. So there is our answer. Yeah. All right, so I'm going to show you how to do this using your scientific calculator, because why not just let the calculator do the work? So let's see here. Pull the problem back up. All right, 8.13, and also double check my math too. I'm doing it this way. Hit second, hit that apostrophe if you have the, or the comma if you have the TI-84, and then you don't have to raise this exponent because the calculator knows it to do that. All right, divided 3.8, hit that second comma for the times 10 to the, and then go right to that exponent. All right, now the benefit of doing it this way is that your calculator, when you write it this way, treats that whole scientific notation thing as one number. All right, whereas if you do 3.8 times 10, you got multiple operations, and then you're going to run it. You're more likely to run into order of operations or lack of parenthesis, kind of careless error. So, and this is just faster. So always use that second comma for that E, for which means times 10 to the, and let's see if we get the same answer. We do. All right, now you're going to have to rewrite that in scientific notation and trim the sig figs, but you still get 2.1 times 10 to the 2, which is our answer.